In this lesson, we're going to take what we learned about linear inequalities and apply it to systems of linear inequalities. A system of linear inequalities is when you have two or more inequalities that are graphed together. And they're going to be graphed together or solved together because the two inequalities are part of the same situation. So when we talk about the solution to a system of linear inequalities, the solution is going to be the overlapping region. So remember, with linear inequalities, we shade it either above or below the line. We're going to do the same thing here, but since you have two lines, you'll have a region where your two shading regions meet. So the part where it meets is going to be your solution. So the solution is the overlapping region of points that make both equations or both inequalities true. So let's take a look at a few examples together. And remember, you're going to need two different colored, either colored pencils or crayons. So taking a look at number 1, we know that we have a system because of the bracket joining our two inequalities together. So both of our inequalities need to be written in the form y equals mx plus b. And both of these are. So I can graph them just like they are. Remember, we start by graphing the y-intercept first, and then we graph the slope twice, and then we shade based off of the inequality. So our first one, and I'm going to label it as a number 1, so when I look at my graph, I know which one I'm talking about. My y-intercept is at -1. My slope is -1 over 1, so we're going to go down 1, right 1, down 1, right 1. And because it's a greater than sign, it's going to be a dashed line. And then greater than means we're going to shade above the line. So that means I'm going to shade this part of my graph. Then I'm going to graph my second line, and I'm going to put a number 2 beside that so I know from my graph which one is which. My y-intercept is -5, so from my origin I'm going to go down 5. And then my slope is a positive 1 over 1. So I'm going to go up 1, right 1, up 1, right 1. Because my inequality symbol is less than, it's a dashed line. And because it's less than, we're going to shade below the line, which would be down here. So once I have graphed and shaded both lines, we want to find the area where those two shaded regions meet. So where on my paper I have yellow and green overlapping. So those shaded regions, or the shaded region where they meet, would be right here. And we're going to put a big S there to show that that is my solution set. So any point that I pick within that region where my two shaded regions overlap, any of those points would make this system true, because any of those points make both of my inequalities true. Go ahead and highlight number 2, and let's take a look at number 3 together. So we're going to do the same thing, except for on number 3, my first inequality is not written in the correct form. So I need to rewrite it so that it is y equals mx plus b. So to rewrite it, I'm going to move my x over. That would not change my inequality symbol. But then I need to divide everything by -4. This would change my inequality symbol. So it would be y is greater than or equal to 1/4 x minus 6. So now I'm going to graph this inequality that I just rewrote, and then the second inequality in my problem that was already in slope-intercept form. So let's start with the one that we rewrote. We're going to graph it. I'm going to go ahead and put a number 1 beside it. And then when I graph it, I'm going to go down 6 on my y-axis. And then from there, I'm going to go up 1/4. And then I can't do that. Oh, I might be able to do it again. Up 1. I can't. Over 4. And because it is a less than or equals to, greater than or equals to, the equals to tells me that I have a solid line. And then the greater than tells me it's going to be shaded above the line. So this whole area. Next, I'm going to graph my original inequality up here. Y is less than or equal to 2x plus 1. So the plus 1 means my y-intercept is at positive 1. Then my slope is 2/1. So I'm going to go up 2/1. Up 2 over to the right 1. And because it is less than or equals to, I'm going to have a solid line. And then the less than means it's going to be shaded below it. So shading below would be down here. And where my yellow and green intersect, those shaded regions, would be this whole area right here. So any ordered pair within those joining shaded regions would be a solution to this system, because I can pick an ordered pair. So for an example, I could pick the ordered pair 0, 0, plug 0, 0 into both of these inequalities, and they would make both of them true, just like we did in the previous lesson. Let's take a look at number 4. So number 4, we have two things going on. We have a special case, x is less than -4, and we have an inequality that needs to be rewritten. So let's go ahead and rewrite that inequality. So bringing our 3x over, that would give us 2y is less than or equal to -3x minus 2, because remember we're subtracting 3x from both sides. Then I need to divide everything by 2. This would not change my inequality symbol. So y is less than or equal to -3/2x minus 1. So then we're going to graph this equation I just rewrote, and we're going to graph that first equation that did not need to be rewritten. So let's start by graphing this first one, this special case. So x is less than -4 means on our x-axis we need to go over to -4, and then we would have a horizontal line, and that horizontal line is going to be a dashed line because it's a less than symbol. And less than means we're going to shade to the left of this symbol. So we're going to shade it all over here. So all of these would make this inequality true. Then we're going to graph the one that we just rewrote. Label that with the number 2. Our y-intercept is at -1, so I'll go down here to -1. My slope is -3/2. So that means I'm going to go down 3, right 2. Remember, rise over run. So from our y-intercept, down 3, right 2. And we're going to do it again, down 3, right 2. And it's a less than or equals to, which means it would be a solid line. And less than means we're going to be shading below that line. So below the line would be here. So the area where these two cross is this section right here. So again, we can pick any point within that section and it would make both of these true. go ahead on this page and highlight number 5 and 6. And on your next page, you also have some special cases as well. So go ahead and highlight 7 through 12. Make sure you're rewriting them if they're not in slope-intercept form. And then take a look at your application. And you can highlight that one. We are going to take a look at applications in our next lesson, but I wanted you to go ahead and start thinking about them. So Sarah's Pet Store never has more than a combined total of 16 cats and dogs. She also never has more than 9 cats. Write a system of inequalities and graph to show the possible numbers of cats and dogs in her store. So based off the information, there can be several combinations that would make this true. So you want to do like we've done before, where you write your let statements. So let X equal your cats and let Y equal your dogs, because those are our two subjects. And then you're going to write your system based off the information given. So when you take a look at the problem, it says the store never has more than a combined total of 16 cats and dogs. So that means the number of cats and dogs added together can't be more than 16. So it has to be less than 16. And then our second statement would come from, she also never has more than 9 cats. So that one, we would just be using our X variable to write it. So give this application a try also with your other highlighted problems.